we go. And
We're recording.
yep, we should. Are we're recording, right? Yeah. Okay, we're recording. Okay, perfect.
All right. So I'll just introduce myself. You guys can introduce yourselves and then we'll go over the rocket.
Okay.
So I'm Bob Schoner. I am the safety reviewer for the Chico rocketry team number 68, team number 12. This is their safety review. So go ahead and introduce yourselves.
All right. I'm Enrique Borgsener, and I am the president of the Chico Rocketry and Aerospace Club.
And I'm Kyle Chen, secretary of Chico Rocketry and Aerospace.
What role did you play in building a rocket, Kyle?
I helped a lot with manufacturing, and most of the eBay is my doing.
Okay.
Yeah.
All right. And I don't know, I still have this meeting is being recorded on my screen. I don't know if that's make that go away.
Pardon me?
Whoops. Sorry, I'm trying to make this meeting is being recorded go away from my screen, but
Yeah.
I don't know if that's something you can control and close.
I don't
not
think
really.
so. No.
I think that's client side.
Huh. All right, let me just try something for a minute. Account owner can watch. No, that's not it. All right, well, I guess that's just going to be in the middle of the screen for me. All right, let's just go over the rocket again. I guess, just tell me a little bit about your nose cone, the material. Yeah, just so go over the nose cone material and the shoulder length and how it's attached.
Okay. So the nose cone. The nose cone is made out of G12 fiberglass. It is a 6-inch outside diameter, and the shoulder length is 6 inches as well. It is attached through the use of 3 1/4-20 screws, which screw through the nose cone, a coupler, and then into a metal bulkhead. And in terms of how the screw attaches, it goes into dowel nuts, and those dowel nuts rest in that bulkhead.
Okay, and this nose cone is remaining attached to the rocket.
Yes, yeah, this nose cone
Okay.
is remaining, or it's completely attached, and nothing comes off of it. So
There's another separation point below it.
Yeah.
yes, yeah. So this is the separation point right here under the payload.
Okay. Tell me a little bit about your body tubes. Yeah, just the body tubes for the rocket and the couplers for the body tubes.
So the body tubes of the rocket, they are G12 fiberglass as well, as are the couplers. And the body tube is 6-inch outer diameter. And in terms of the couplers have 6 inches of coupler length for separation. So where all the shear pins are going, there's 6 inches there, and at least. And then we have all other attachment methods are attached through the use of 3 1/4-20 bolts bolted into dowel nuts, and those dowel nuts are retained by either wood or metal bulkheads.
Okay, that sounds good. And just a reminder, it looks like you probably still are going to do painting, but just a reminder that you need your team number. And if you're transmitting anything, you also need the frequency on the outside of the rocket.
We'll do that, yes.
And we will be painting our rocket sometime in the near future.
The next couple of weeks.
Yeah.
All right. Let's see. Shoulder length is good. Attachment. So there's electronics in the coupler. I'll talk about that when we talk about. Well, let's talk about that now.
Right.
So
What are your electronics for recovery?
Yeah, so this coupler in the middle of the rocket is our main eBay. And that's where we're housing both our primary and secondary flight computers. Our primary is a Telemega and our secondary is an Easy Mini. And there's also going to be an array of 4 cameras in here recording 4 different angles.
Okay. You just storing the data for the cameras?
Yeah, on board, yeah. That's
Have
not,
you, I know sometimes they can stay on the pad a long time. Hopefully you have good batteries and large memory chips, so,
yeah. Yeah,
all right.
on board, yeah.
Let's see, I thought there was something else I needed to ask. All right, I'm not seeing that yet. Okay. Um, so the batteries that you're using, don't have any LiPo batteries, is that correct?
They're not LiPo batteries.
Okay. And tell me about your shock cords, the material and the length.
It's 1/2 inch Kevlar shot cord. And the drogue will have 12 feet and the main will have, or not feet, meters, they'll have 12 meters. And the main will have 6 meters.
Okay. What is the size of your drogue and main?
Our main chute is gonna be a 10-foot chute and our drogue is a 5-foot chute. And the main chute should have a descent rate of about 16 miles an hour and the drogue will be about double that.
16 miles an hour. Do you know what that is in feet per second? I don't
Oh,
think it's probably like 20-ish. I'm not sure.
hour, what's 16? Feet per second, it's about 23 feet per second.
Okay. All right. And tell me about your so the parachutes, are they all commercial or did you make those?
Yeah, those are all cots,
Okay.
all fruity shoots.
All right, those are nice.
Yep.
Tell me about your shear pins at your points of separation.
Yeah, so the shear pins, we're gonna be utilizing 3 440 shear pins. And they're essentially going directly from the airframe fiberglass tube to the coupler fiberglass tube. And then they're gonna be retained by nuts on the end, on the inside.
And those are nylon, I guess.
Yes, they're nylon shear pins and nuts as well. So,
Okay, and you're using black powder for deployment?
yes. Mhm.
And you still are gonna do some ejection testing, right?
Yes, we plan to do ejection testing
Today.
probably today.
Yeah.
Okay. Another hint I would tell you is if it's a windy day, don't ejection test with your parachute.
Yeah,
Okay.
yeah, that's a good idea.
I've seen ejection tests drag rockets across roads and it's a
Wow.
mess.
That's scary.
You using any deployment bags or Nomex or dog barf?
We have no mechs for both shoots.
Okay. And let's see. Your hard points, you have U-bolts and quick links, right?
Yes.
Mhm.
Mhm. And the quick links and U-bolts, I believe, are both of them, I believe we made sure to have them rated for over 1,400 pounds.
Okay. Your Kevlar, does that have sewn loops or are you tying knots in it?
I think they have, do they have? I think they have some, do they have some loops in there? I believe.
Yeah, I think the guy who usually sets up our recovery system isn't here, so we're not sure, but I think there are some loops in there just to hold on to the chutes.
And I think we might be tying a knot or two.
Yeah,
Yeah, we might be tying a knot or two in the cord at. Yeah, certain.
Okay.
locations.
And I'm sure, you can review that when you get to Spaceport too, that'll be checked.
yeah.
Um, your vent holes and switches, you have switches mounted externally,
Yep.
screw switches, right?
Yeah, they're key switches and they can all be accessed externally.
Okay, and tell me about your altimeters, primary and main, or primary and secondary.
Yeah, so those are both Alta Spectrum ones. We're running a Telemega for our primary and an Easy Mini for our secondary.
Okay, what's your deployment altitudes or times?
The drogue is, I think, apogee plus half a second. Or yeah, something like that. And then our main shoot deploys at about 1,000 feet.
Okay, and what about for backup? Same or,
Yeah, I believe it's the same.
Yeah, the backup should be,
Or it might be like offset like a second.
Yeah.
Or something. Yeah,
something like that, yeah.
okay. And tell me about the motor you're using.
we are using an M2500
Yeah,
motor and
Aerotech.
we are using an Aerotech case. With that,
Okay,
all COTS.
and you do have the forward closure for that, or the forward seal disc?
Yes. Yeah, we do.
Okay. Sometimes those get thrown out and that's expensive.
Yeah,
Don't do that.
Yeah,
I think that did that happen last year?
we left the part here.
Oh, yeah, we left it last year, yeah. So
Oh,
similar issue. This year we won't.
okay.
Lesson learned.
Yeah.
Tell me about your payload.
So our payload is, it's a 3U CubeSat. It is gonna be one single piece, and we are testing a Tesla valve and the properties of it under rocket ascension. And it is mounted in the nose cone section, so it's actually
Just under the
mounted
nose cone.
under the nose cone in the 1 foot airframe. And it is inside this section, so there is a hole cut out for the payload bay. And essentially the way we structurally ensure the nose cone area to work properly is that we have the two couplers here, and then they are JB welded completely to the airframe. And then there are 3 all thread rods that go from a JB welded bulkhead up to the screwed in metal kind of like a centering ring almost, and pretty much a bulkhead.
These will be cut down as well.
And
These are just-
yes, yeah, these are going to be cut down. And so we have those rods coming up, and then we have 3D printed pieces which have holes for the rods, and it helps prevent the rods from bowing and buckling. And then for the panel piece, we utilize 4 1/4-20 screws to bolt the panel piece on from all 4 corners of it. And those bolts run through the fiberglass into a 3D print, and inside the 3D print are 1/4-20 dowel nuts. So the 3D print is only holding the dowel nuts. And that is
Okay.
how it's all being retained.
Okay. Let's see, and that stays attached, that's not getting deployed.
Yes,
Yeah,
yeah,
the
everything
payload's
stays
not gonna-
attached, so this is all gonna be one piece and come down just like this.
Okay. All right, that sounds good. Let's see. Just looking at some other stuff, propulsion section, so that's also fiberglass cots. Thin material,
Aluminum, yeah, the thin material is, it's all 6061 aluminum. And for the mounting system, we utilize T-bar to bolt everything together to the centering rings, and the centering rings, as well as the T-bar, are 6061 aluminum. So everything is.
and that's through the wall to the T-bars.
Yes, yeah. So
Okay,
it's everything's an internal mounting system, so it, in fact, we take the rocket part, and
okay.
out that whole system.
Have you done any fin flutter analysis on that?
Not
We,
yet.
no, we have,
have?
yes,
Oh,
we
okay.
have. I don't know the numbers off the top of my head, but we did do fin flutter analysis and, like I said, I don't know it off the top of my head, but we did it in one of the technical reports. And, that design that we chose to make sure that fin flutter analysis was okay, we've kept that fin design and we haven't changed it at all, so.
Okay. So yeah, it just needs to be at least 50% higher than the expected maximum rocket velocity. You're not gonna go above Mach, I don't believe, with that.
No, I believe we're gonna be somewhere around Mach 0.9, so that's kind of like our around that
Yeah,
area.
okay, that sounds about right. The motor tube, is there a fiberglass motor tube or is that just,
It's a fiberglass motor tube on the inside.
okay? And the centering ring material,
It's a 6061 aluminum.
okay? And how are they attached to the body tube?
So the centering rings are bolted and they, it utilizes, so there's three, three centering rings. Each one has 3/4-20 screws and it does not tap directly into the centering ring, but rather it goes into dowel nuts. And so those dowel nuts are what retain the bolt together.
Okay. And rail buttons, you
Yes.
said they were apogee rail buttons are
Yes.
coming.
So they're apogee rail buttons and we plan to have 3 rail buttons. So on each one of the screw sections, we're gonna have a rail button. So that's pretty much the
Okay.
location of where they are.
All right, that looks good to me. The boat tail, you have a nice boat tail.
Oh, yeah.
Tell me about the material for your boat tail.
So this is not the actual boat tail we're gonna use. The real boat tail we're gonna use is going to be comprised out of carbon fiber nylon. It's gonna be 3D printed. And right now, this is just ABS. It is just a prototype, so.
Okay. And how's your motor retained? What kind of motor retention do you have?
The motor retention we have,
The normal like Aerotech one.
yeah, we have the Aerotech
Screws on,
It
yeah.
screws on, and the base of that flange is bolted onto the centering ring. So we have the centering ring, the flange is bolted on, and then it screws on.
Okay, so you have yeah, I've seen those flanges
Yeah,
before. Okay,
off the shelf, yeah, retainer.
yeah. Okay, I appreciate your time. Do you have any more questions for me?
Good.
Yeah, we're good.
All right, so the rocket was present. I think the team is ready. We weren't able to have the fire record or the mentor there, but they are good to go for to Spaceport. And you have the hardware for your motor. Your motor will be delivered to Spaceport.
Yep.
I think that's good to go. Just don't forget to drill your vent holes and add some team numbers to your
All
to
right.
your airframe when you're done.
Yep, absolutely. Thank you so much.
Yeah, thank you.
All right, appreciate it, guys. We'll see you in New Mexico.
Yep,
All right, yeah.
will do. See you later.
Okay, thanks.
All right.
Bye-bye.
Bye.